An interesting case in modulation is obtained when we set omega to be equals to pi. Then the modulating function is just a sequence of plus or minus 1, and multiplying the sequence with our signal results in a frequency shift of pi. In this case, if we have a real valued low-pass signal, for instance, then this will be shifted by pi and we will obtain a high pass. In this way, we can turn the impulse response of a low pass into a high pass and vice versa. So here we see that we have this low pass and we shift it by pi, which is also modulating, when the modulating function is just a sequence of plus or minus 1. We set our omega equals to pi and it will modulate, and we will have this high pass, for example. Another important tool is the so-called reversal of the ordering of a finite length signal sequence with length L, meaning that xn is non-zero only for n going from 0 to L minus 1. Well, we have this sequence here, and then the z transform is given here, and we can now reverse the order of the summation, of course without affecting the result, by starting at the highest index and going to the lowest, replacing the index n by the expression L minus 1 minus n prime. So this is an index substitution, and we end up with this, or in short, we end up with this. So what we obtain is the inverse of z in the z transform, which signifies the time reversal, and a factor of z to the power of minus L minus 1, which is simply a delay of L minus 1 samples.